Tutorial number 1E, Deterministic, Semiprobabilistic, Probabilistic Analyses. Let's consider a planar sliding bench block, subjected to the self-weight and to 2000 kN external load, representing an excavator. In the deterministic approach, each data of the problem is a known number. In the probabilistic approach, the problem's data are variates with Gauss probability distribution. A mean value and a standard deviation must be assigned for each input data. In RockBlocks, the free surface geometry is considered a perfectly known input data. The joint's orientation angles and their strength parameters can be statistical variates. The actions too can be statistical variates. Deterministic analysis. Open the job file tutorial number 1E, where the deterministic analysis option is selected. When using a deterministic approach, the input mean values are considered a reasonable estimation of the data. Typically, the average joint's orientation angles are input. And conservative estimations of the strength parameters. And conservative estimations of the actions too. In a deterministic analysis, the working stress calculation method is used. The standard errors of the data are disabled. Only the mean values of the parameters are used in the calculation. The computed safety factor SF has a precise physical meaning. The fraction of SF exceeding 1 is the strength reserve. Generally, the minimum acceptable deterministic safety factor is 1.3. That is, at least 30% strength reserve is required. Here, the computed safety factor is 1.574. The strength reserve is 57.4%. The actual strength is 57.4% larger than the strength strictly required for the equilibrium of the block. Semi-probabilistic analysis. Select the semi-probabilistic analysis option. In a semi-probabilistic analysis, the standard errors of the joint's orientation angles are disregarded in the computation. Whether the strength and the actions are statistical variates, the mean value plus the standard deviation must be assigned for each strength and load parameter. The characteristic value of each strength and load parameter is computed, starting from the mean value and the standard deviation. The characteristic value xk of a strength parameter x is the 95% confidence limit, so that the probability that x greater than xk is 95%. The characteristic value fk of the actions parameter f is the 95% confidence limit, so that the probability that f less than fk is 95%. In a semi-probabilistic analysis, the ultimate limit state calculation method is used. In the ULS calculation, the strength parameter's characteristic values are reduced by partial safety factors. And the actions parameter's characteristic values are increased by partial safety factors. The reduced strength parameters and the increased load parameters are named design values. The computed safety factor has not a precise physical meaning, rather, it is a conservative statistical estimate, where SF equals 1 means low probability of failure. In most cases, the minimum acceptable semi-probabilistic safety factor is 1.1. Full probabilistic analysis. Select the full probabilistic Monte Carlo simulation option. In a full probabilistic analysis, the data Gauss probability distributions are used to perform a Monte Carlo simulation. The variates data are the joint's geometry, the joint's strength, and the actions parameters. Then, the working stress calculation method is used to compute the safety factor of each random generation of each block shape. For each block shape, the result is the probability distribution of the safety factor.